Hello everyone, my name is P. Lavanya, working as Assistant Professor from EC Department in Marri Laxman Reddy Institute of Technology and Management. Today I am going to explain about amplitude modulation from the subject Analog and Digital Communications. Introduction to this subject. What is modulation? Amplitude modulation, time domain description of AM waves, generation of AM waves, demodulation of AM waves, and summary. So modulation. What is meant by modulation? Modulation is the process in which the characteristics of the carrier wave is varied in accordance with instantaneous values of the modulating signal. So what are the characteristics of the carrier wave? What is meant by carrier wave? Carrier wave is a high frequency signal. So what are the characteristics of a carrier wave? The characteristics of carrier wave are amplitude, frequency, and phase. So carrier wave is represented by Fc is equal to carrier frequency. Fc is equal to carrier frequency, and carrier wave signal is represented by C of t is equal to AC cos omega Ct plus phi. So AC cos 2 pi Fct plus phi. Here AC is the amplitude and Fc is the frequency and phi is the angle. So these are the characteristics of a carrier wave. In modulation process, what we do is the characteristics of the carrier signal, which is a high frequency signal, is varied in accordance with the message signal. So if amplitude is varied, then that is called amplitude modulation. If frequency is varied, then that is called frequency modulation. If phase is varied, then that is called phase modulation. This is about modulation. Next, what is the necessity of a modulation? So first point, suitable for signal transmission. So for long distance transmission, low frequency signals cannot be transmitted over a communication channel. So because they are very low in frequencies, for that purpose we need to convert that low frequency into high frequency signal. So that low frequency signal is translated into high frequency signal. That is called modulation process. Next, multiple signals transmitted on the same channel. Here, multiple signals transmission is called multiplexing. Multiplexing is the process in which number of signals can be transmitted into through single channel. Okay. Next, capacitive and inductive devices require high frequency AC component to operate. Next, stability and noise rejection. This is about modulation and what is the necessity of a modulation. Next, basic modulation types. So basically modulation is categorized into continuous wave modulation and pulse wave modulation. Again, continuous wave modulation is categorized into amplitude modulation and angle modulation. So amplitude modulation further divided into double sideband full carrier, double sideband suppressed carrier, single sideband suppressed carrier, and vestigial sideband. Next, angle modulation. Angle modulation is categorized into frequency modulation and phase modulation. Coming to pulse modulation, so digital pulse modulation technique and analog pulse modulation. So digital pulse modulation technique comes under pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. So analog pulse modulations are pulse amplitude modulation, pulse width modulation, and pulse position modulation. These are the basic types of modulation systems. Next, amplitude modulation. So what is meant by amplitude modulation? So amplitude modulation definition is the amplitude of the carrier wave is varied in accordance with instantaneous values of the modulating signal. So this is called amplitude modulation. Here, in amplitude modulation, the characteristics, amplitude of the carrier is varied. So here we have carrier signal C of t and message signal M of t. So here message signal is, or modulating signal is, a low frequency signal, and carrier signal is a high frequency signal. So the carrier signal is represented by cos 2 pi Fct. Actually C of t is equal to AC cos 2 pi Fct, or we can write it as cos omega Ct. So omega C is the angular frequency, which we can write as 2 pi Fc. Next, coming to modulating signal M of t is represented as M of t is equal to AM cos 2 pi fmt or AM cos omega MD. We know that omega M is a angular frequency, so we can write it as 2 pi FM. This is carrier signal and modulating signal. And the amplitude modulated signal is given by S of t is equal to AC plus M of t cos 2 pi FCT. After modulation, we'll get AM signal as S of t is equal to AC plus M of t cos 2 pi FCT. So amplitude modulation, simply we can call AM modulation. So AM signal is generated using multiplier. All information is carried in the amplitude of the carrier, and AM carrier has time varying envelope. Next, in frequency domain, AM wave are the lower sideband and carrier frequency and upper sideband frequencies. Coming to amplitude modulation, so we have three types of frequencies. So amplitude modulated wave contains three types of frequencies. First frequency is FC, that is carrier frequency, and we have upper sideband frequency, we'll simply call USB, FC plus FM. FC plus FM is, FC is carrier frequency and FM is modulating signal frequency. And lower sideband is simply called LSB, that is FC minus FM. So amplitude modulated wave contains three types of frequencies: carrier frequency, upper sideband frequency and the lower sideband frequency. Coming to amplitude modulation and demodulation, here in amplitude modulation and demodulation, in modulation what happens, low frequency signal which is modulating signal and high frequency signal which is carrier signal, both are combined. So low frequency signal is translated into high frequency signal. After that, demodulator means here demodulation process is done. What is meant by demodulation? Demodulation is nothing but reconstruction of original message signal. Here in modulator what we are doing, we are adding a low frequency signal with the high frequency signal. Here in demodulator what we are doing, we are separating a low frequency signal and high frequency signal. So low frequency signal is nothing but modulating signal, information signal, or we can call that as a baseband signal, which is having a frequency of FM. And next, original signal is recovered at the demodulator. So here modulating signal, baseband signal is given to modulator. After modulator, we'll get a amplitude modulated wave. That amplitude modulated wave is given to the demodulator. Finally, we'll receive the same signal which we sent here, baseband signal. Next, AM signal mathematical expression. So AM signal is represented by S of t, that is equal to AC into 1 plus K M of t cos omega CT. So here K is called amplitude sensitivity. K is called amplitude sensitivity. So we know that omega C is the angular frequency, AC is the carrier amplitude of the carrier. So for AM signal, this is the representation of a AM signal. So AM signal is represented like this. So AM signal is represented like this. Okay, next, modulating signal. Modulating signal is represented by M of t. So that is just sinusoidal signal. Next, carrier signal is C of t is equal to AC cos omega CT. So carrier signal is represented like this. M of t means it is AM cos omega MT. By combining this carrier signal and modulating signal, we'll get AM signal. Next, spectral components of AM. In frequency domain, it consists of lower sideband frequency, carrier frequency and upper sideband frequency. So lower sideband frequency is FC minus FM or minus FC plus FM. Next, carrier frequency is FC. Upper sideband frequency is FC plus FM or minus FC minus FM. So next, modulation index of AM signal. For sinusoidal signal, we'll represent modulating signal is equal to AM cos 2 pi FMT, and the carrier signal is C of t is equal to AC cos 2 pi FCT or cos omega ct. The modulated signal is given by S of t is equal to AC AC plus m of t cos omega ct. By taking here from S of t is equal to AC, at the place of m of t we can write am cos omega mt. Next, taking AC common, here we'll get am by AC. This am by AC term is called as a modulation index. Here, what is am? It is amplitude of the modulating signal. Amplitude of the modulating signal. Amplitude of modulating signal, and AC is amplitude of carrier signal. AC is amplitude of carrier signal. So what is meant by modulation? Modulation index mu is equal to AM by AC. It is the ratio of amplitude of modulating signal to the amplitude of carrier signal, AM by AC. So next, the modulation index for the envelope of AM signal in terms of maximum and minimum envelope amplitudes, it is derived from the envelope peak variations. Here amplitude modulated wave is represented in this way. So here it is maximum amplitude, we call it as A max, and here it is minimum amplitude, we call it as minimum. Taking consideration of maximum and minimum amplitudes of AM wave, we can define modulation index as mu is equal to A max minus A minimum by A max plus A minimum. Here mu is the modulation index, A max is the maximum amplitude of the envelope, A minimum is the minimum amplitude of the envelope, which we have written here. So these are the maximum and minimum amplitudes. Next, so modulation index, depending upon the modulation index, we will have types of AM waves. Means suppose mu is equal 0. So this means mu is equal 0 means modulation index is equal 0 means no modulation. We'll call under modulation. When mu is equal to 1, 100% modulation, or we can call it as perfect modulation. When mu greater than 1, it is over modulation. So the resulting waveforms will be like this. For the under modulation, the waveform will be like this. For perfect modulation, waveform will be like this. For over modulation, the waveforms will be like this. This is about modulation index of AM wave. Coming to power calculation. So here the total power in amplitude modulated signal is sum of carrier power and the power of two sidebands. Sum of carrier power means PC, and sum of two sideband power. So we know that we have three types of frequencies: carrier frequency, upper sideband frequency, and lower sideband frequency. The power of the upper sideband will be P USB and power of the lower sideband will be P LSB. So the total power is given by, it's a sum of carrier power and the sidebands power. The formula for total power is given by PT is equal to PC into 1 plus mu square by 2. So PT is total power and PC is the carrier power. Here mu square means mu is modulation index. Here carrier power is represented as PC is equal to AC square by 2R. So AC means amplitude of the carrier signal. Coming to sideband powers, P USB, P LSB is equal to PLSB is equal to PC into mu square by 4. So total sideband power we can write as PSB is equal to PC mu square by 2. This is about power calculation in AM wave. Total power is equal to PC into 1 plus mu square by 2. PC is the carrier power, mu is the modulation index. Next. So here, to generate amplitude modulated signal, we have some modulators. Here, square law modulator. It is one type of AM wave generator. Here, this is the block diagram of a square law modulator. Here you have a summing device and square law device and a band pass filter. Here Square law modulator is a type of amplitude modulation technique used in communication system. It works by multiplying carrier signal with the message signal using nonlinear device, operating it in square law region. Here for it is a summing. Here it is a summing device. For this summing device, we are giving M of t modulating signal and C of t carrier signal. Here what happens here? The multiplication process happens here, and that signal is given to the square law device. After square law, we have band pass filter. Band pass filter means it allows only band of frequency. The resulting waveform is a AM signal. S of t is equal to AM signal. So here we have some points about square law modulator. First one is nonlinear device. Nonlinear device, it may be diode or transistor. Operates in square law region, enabling signal multiplication. Next, carrier signal generator. So for generation of carrier signal, we use oscillators. It produces a high frequency carrier wave. Message signal source. So provides input information, voice or data. Filter, band pass or low pass filters. Band pass filters are used in generation technique. Low pass filters used in demodulation techniques, detection techniques. Okay, removes unwanted frequency, extracts modulated output. Next one is summing circuit. Combines carrier and message signal for the modulation process. So next one. So in modulation process, what happens? The carrier signal and modulating signal both are combined and are transmitted to the channel. Coming to the demodulation or detection. So we know that demodulation or detection is nothing but reconstruction of original message signal. Here in demodulation amplitude modulator, we use envelope detector. So this envelope detector means a diode circuit with the capacitor and a resistor. Here, if you see, first part acts as a half wave rectifier, second part acts as a low pass filter. Okay. When amplitude modulated signal is given to the diode, okay, when positive for the positive peak, the capacitor will charges. For the positive peak, suppose this is the amplitude modulated wave. This is the amplitude modulated wave. For the positive peak, capacitor charges. When the negative peak comes, it again discharges. For the positive peak, it again charges. For the negative peak, it discharges. Charging and discharging place takes. Charging of the capacitor happens when diode is positive. When input is positive, diode will be non-condition. With that, capacitor will charges to the peak value, maximum value. When diode is in off condition, the capacitor will discharges to the resistor R. So the charging and discharging paths will be like this. So this signal is given to the low pass filter RC combination. A low pass filter means it allows only low frequency signal. The resulting waveform will be a modulating signal. This is about the envelope detector demodulation process of AM wave. Envelope detector is a simple circuit used to demodulate an amplitude modulated signal and recover a original message signal. It consists of diode, capacitor and resistor in series. The diode rectifies the incoming AM signal, allowing only one half of the waveform to pass. It allows only, in the previous it is an input. Here we have both positive and negative sides. So after rectifying, it will have only positive side. Okay. The capacitor charges to the peak value of the input signal and discharges slowly through the resistor R, thereby following the envelope of the modulated wave. The voltage across the resistor represents recovered baseband signal or message signal. This is about the demodulation technique, envelope detector. So coming to applications of amplitude modulation, modulated wave. It is used in radio broadcasting for transmitting audio signals over long distances. Used in aviation communication between aircraft and control towers. Used in two-way radio communication system. Used in analog television signal transmission. Used in communication system for transmitting voice signals. These are the applications of amplitude modulated waves. Amplitude modulation. Coming to summary, so we have discussed about modulation, amplitude modulation, modulation index, generation of and detection of AM waves, and total power of the AM wave, and applications of AM wave. So modulation is the process in which the low frequency signal is translated into high frequency signal. So this process is called as a modulation. So if the definition for modulation is the characteristics of the carrier wave is varied in accordance with instantaneous values of the modulating signal. So what are the characteristics? Amplitude, frequency, phase are the characteristics. Here, if an amplitude is varied, then that is called as a amplitude modulation. This is all about the amplitude modulation in analog and digital communication system. Thank you.